Let's solve a few of these problems involving a small sample confidence interval. Let's use this formula, which is very similar to the large sample confidence interval, but instead of a z, we have a t alpha over 2, where t alpha over 2 is based on n minus 1 degrees of freedom, where n is the sample size. There's the sample size there, n, and the confidence interval that we're interested in, 90%, 95%, 99%, etc. Now for the small sample, we need to make sure that we are sampling from a population that has an approximately normal distribution. So let's solve some of these. Here's problem 527 and 528. Let's do these two problems. In 527, we're going to destructively sample some wood, 25 pieces of wood, to see if we can estimate or infer what the rest of our wood in our factory can withstand. So we'll take a sample of the population, and then we'll create a confidence interval that we think the true mean of the population is somewhere in this interval. So we take a sample of 25, so n equals 25, degrees of freedom equal 24, and the sample mean was 75.4, and the standard deviation around the deviation around that sample mean was 10.9, so the average deviation was 10.9 from 75.4. And then we will simply write out the formula. So the formula is x bar plus or minus t alpha over 2 times s divided by the square root of n. Well, x bar is 75.4 plus or minus, we need to look that up. S is 10.9 divided by the square root of 25. That's the sample size. So we need to look up this t alpha over 2. That's in the back of the book. It was a 90% confidence interval that we were interested in, and the sample size was, let's see, what was the sample size? It was 25. So 25 sample size, and 90% means that there's a 10% alpha. Half of 10% is 5%, so there's the column that we'd use. And if we go down, that is 1.711. That's corresponding to 24 degrees of freedom. And so 1.711 is the number that goes in here. And if you multiply that out, you would get 3.73. Let's do another one quickly, because I want you to actually solve these. This is a length of stay. The average length of stay for male patients is 5.2 days across the country in the United States. And for women, it's 4.5 days. A random sample of 20 hospitals in one state had a mean length of stay for women of 3.8 days and a standard deviation of 1.2 days. So what's our 90% confidence interval to estimate the population mean length of stay? Well, the point estimate of 3.8 is a pretty good estimate of the true mean. And then we need this t alpha over 2 that corresponds to a degrees of freedom of 19. And it was 1.2 over the square root of 20. So if we looked this up, I guess I can do that. We'll look that up. It's 19 degrees of freedom, and it was the same 90%. So 19 degrees of freedom, looks like it's 1.729. So 1.729 is the number that goes in here. And if you multiply that out, you'd get 0.464. And you'd find that the 5.2 is not included in this confidence interval. So we're 90% confident that this state, whichever state it is, has a smaller or shorter length of stay for women than the rest of the country. That's the type of conclusion that you can make.